Okay, let's continue our last topic for this week by discussing work. Okay, alright, so we know that gas have kinetic energy. So we want to exploit that. We want the gas to do some work. Okay, so normally, okay, the easiest way to understand it is to imagine engine. Okay, an engine. So first, how does an engine work? Okay, so engine work, okay, when the gas in it explode or combusted or expand, and the gas push the piston down, and as a result the engine will rotate. Okay, so gas expand and push the piston down, so it will rotate the engine. So in this case we say engine does work. Okay, the engine does work. Okay, so it depends on the engine, car, lorry. So number of piston are varied from one transportation to another transportation lah. Maybe lorry lebih banyak atau lain punya piston. Okay, definitely size berbeza lah. Kereta sport mungkin piston dia lebih berbanding kereta biasa. In thermodynamics, work occurs when gas is allowed to expand or compress. So whenever there is expansion or compression, so we say work happen. Okay, work occurs. Okay, in order to explain this, okay, there is one sentence that we have to be careful, which is work done by or work done on. Okay, both of these carry different meaning. So for example, I can say work done by the gas or work done on the gas. Okay, it represents two different things. One represent expand, okay, another one represent compress. Okay, so let's look which one belong to which. Okay, so for expansion process, okay, where the volume expanded lah, okay, the change in volume is positive. Okay, V final is more than V initial, work is positive. Okay, so the sentence is work is done by the gas. Okay, work is done by the gas. So sometimes uh, we do not say work done by the gas. We say work is done by the system, or maybe work is done by the engine. So it carry the same meaning as this sentence. Work is done by the gas. Okay, work is done by the gas. Work is done by the system. Work is done by the engine. Okay, the same thing. Alright. For next is process where compression. Okay, change in volume. Volume becomes smaller. Okay, so we say work is negative. Okay, the sentence is work is done on the gas. Okay, again another sentence is work is done on the system. Same thing. Okay, work is done on the engine. So it both of the sentence carry the same meaning as work is done on the gas. Okay, see here one word by the gas, this one is on the gas. Okay, work done by the gas, you have to straight away catch that it is expansion. Okay, the gas does some work, it expands. Work done on the gas, this compression process, the value must be negative. Okay, I will show you the example what does it mean by positive or negative. Positive, negative, but please remember that expansion is work done by the gas. Okay, what if the volume remains the same like this? Okay, so in this case, change in volume constant, work is zero. So no work is done. Okay, so for formula, okay, we are familiar with this formula. W equal to Fs. Okay, F delta S. Okay, then F equal to P times A, pressure times area. So area times delta S can be substituted with is equal to change in volume. So this is formula for work in thermodynamics. Okay, P is pressure constant, Vf minus V final. Okay. Okay, please go through my slide, my lecture notes, okay, to understand, to read all this. Okay, so usually in physics, whenever we have equation, we will do experiment to study the equation, the validity of the equation, or what else can we get from the equation. So in this case, we want to do experiment to study this equation. So here we have two parameter, which is pressure and volume, change in volume. So let's do experiment. Okay, so and happen to be we get the value. Okay, P is kept constant but volume expand. So how do we achieve that? How can we do experiment where P is constant but volume increase? So we simply increase the temperature. Okay, it doesn't matter whether we increase temperature or not, because we only care about P and V. So we want to study about P and V. So T not necessarily be constant. Okay, we can increase it. So as long as it gives us value of P and V. Okay, so when we get this table, this data, as usual, we plot the graph pressure against volume. So like this. Okay, we plot. Okay, and arrow should be to the right, to show expansion. Okay, so this graph is called PV diagram. So simple, pressure versus volume diagram, PV diagram. So whenever I say PV diagram, it refers to this graph lah. Okay, so it's simply the readings of the pressure and change in volume plotted on graph. Okay, right. What can we get from PV diagram? Yeah, so this is graph PV diagram for expansion. So from here we know, because arrow is to the right, volume of the gas expand, work is done by the gas. Okay, work is positive. So this one is compression. Okay, sorry, this should be here. Okay, V final is smaller. Okay, here is V initial. Okay, so for both, if we apply formula, we can see that the value of work, if we apply the formula, you will get negative value. Let's say negative 100 joule. This one is positive 100 joule. Okay, so that is mean by work is negative, work is positive. Okay, so this is compression, work is done on the gas. Okay, so what can we get from, what else can we get from PV diagram? So it happen to be that work is actually area under graph. So we can find value of work if we calculate area under the graph. How to calculate area under the graph? Simple, just length of this, value of this times value of this, length of V. Okay, length of pressure times length of V. Okay, simple, basic mathematics. Okay, this is example, please go through. Okay, this is value of P, constant pressure, and then V initial, V final. Okay, simple. You'll get this answer. See, this gas expand, meaning process expansion. Work is done by the gas expansion, and value work of is positive. Okay, work is positive. Okay, we say the work done by the gas. Okay, work done by the gas is positive because it is external. Okay, now next example, an external pressure of this. Okay, this pressure pushes down handle of bike pump until the gas is compressed. Okay, So we know this is compression. Okay, calculate work done. So this is compression, V final smaller than V initial. We straight away know this is work done on the gas, and we should expect work is negative value. So when we calculate, we must anticipate that the value must be negative. Okay, see, we should get negative. If we don't get negative, please check our calculation. Okay, maybe there is some carelessness lah. So here must be negative lah, because final is smaller than initial. Okay, work done on the gas. Okay, work done on the gas. Alright, so another example. Okay, instead of giving change in volume, it gives you area by distance. Okay, calculate work done if the pressure is constant. Again, same formula, except okay, here, okay, this use P A delta S. Okay, we expand the delta V. Okay, so go back to the slide where there is formula of work. Okay, there is delta change in V is actually area times delta S. So you apply this formula, you will get the answer. Work done, this is expand, so expansion, so this must be positive value. Positive value. Work done by the gas. Okay. Okay, so far we have learned that in calculating work, okay, pressure is constant, okay, and volume is allowed to expand or compress. So whenever we see this kind of process, we know that we can calculate value of work. Okay, work is simply equal to area under the graph. So at this particular moment, pressure is constant. Alright, but what if the pressure is not constant? Okay, is there any work, or how to calculate work? Okay, so imagine if the graph is like this. Okay, tadi graph hanya straight line macam tu. Now sengit. Okay, so how do we calculate value of work? Okay, again simple, use our mathematical knowledge. We calculate this area, we plus this area, or simply apply the trapezium formula. So still work is area under the graph, and we should get the answer. Okay, should get the answer. But what if the graph is like this? Okay, or maybe like this, or maybe like this. Okay, still work is area under the graph. Okay, but here this one, okay, we have area under the graph. This one also okay, area under the graph. But do this graph has any area under the graph? No, right? So no work is done because there is no change in volume. Okay, change in pressure doesn't mean there is work. Okay, work must be represented by change in volume. Okay, so this one no work, this one there is work, here also work, but of course the formula should be little bit different lah. Okay, so we will learn in the next lecture, inshallah. Okay, alright, thank you so much.